What if humanity's future doesn't lie on Mars, but on the planet we've been told to fear? What if the very world that now burns hot enough to melt lead, shrouded in choking clouds and crushing pressure, could one day become a second Earth? Could we really turn Venus, the planet of fire and acid, into a home for life? And more importantly, why should we even try? This video will reveal why terraforming Venus may be the most ambitious project we'll ever attempt, and perhaps the only way to secure our future. Welcome to Astroracle, where we explore the vast universe together. When we think about colonizing other worlds, Mars always steals the spotlight. But Venus is actually Earth's closest twin, similar in size, gravity, and composition. Strip away its toxic atmosphere and blistering heat, and Venus looks a lot like home. Here's the problem. Today, Venus is a nightmare world. Its surface temperature hovers around 464 degrees Celsius. That's 867 degrees Fahrenheit. Hot enough to melt zinc, tin, or even lead. The air pressure is 91 times greater than Earth's, like standing a kilometer under the ocean. And instead of fluffy clouds, the sky drips with sulfuric acid. So why Venus? Because if we could fix it, if we could turn hell into paradise, we wouldn't just gain a second Earth. We'd gain the ability to transform entire planets across the cosmos. Terraforming Venus is more than a dream. It's a blueprint for becoming a truly interplanetary species. The first problem is obvious. Venus is too hot. Way too hot. And the main culprit is its runaway greenhouse effect. Thick carbon dioxide traps sunlight, heating the surface until it glows like a forge. The most popular solution? A planetary sunshade. Imagine a vast reflective umbrella stationed at the Sun-Venus Lagrange point, a perfect balance spot in space where the shield would hover and block sunlight. Over decades or centuries, Venus would begin to cool. As temperatures fell, something miraculous would happen. The thick CO2 atmosphere would condense and freeze, blanketing the planet in glaciers of dry ice. For the first time in billions of years, Venus's surface could breathe again. But here's the catch. Cooling an entire planet isn't quick. Even with a massive shade, Venus's atmosphere and crust hold so much heat that the process could take hundreds of years. Terraforming is not a sprint. It's a marathon across centuries. Cooling alone isn't enough. Even if CO2 froze, Venus would still be drowning under millions of gigatons of carbon dioxide. To truly terraform, we'd need to remove or transform that atmosphere. One idea is to use chemistry on a planetary scale. Venus's surface is rich in basalt rock, filled with minerals like calcium and magnesium oxides. These can react with CO2 to form solid carbonates, just like Earth's natural carbon cycle. The problem? Naturally, this process takes millions of years. To make it useful, humans would have to engineer the reaction, perhaps by mining, injecting, or spreading reactive minerals across continents. Picture enormous machines drilling into the crust, sucking in CO2, and locking it away as rock. Another radical idea: bombard Venus with hydrogen. This was proposed by researcher Paul Birch in 1991. By shipping hydrogen from Saturn's moons, or captured comets, and dropping it into Venus's skies, CO2 could chemically transform into graphite and water. Imagine black carbon dust settling on the ground, and entire oceans forming out of thin air. The vision is staggering, but so is the challenge. The amount of hydrogen needed would equal billions of times more than humanity currently produces. Still, if accomplished, Venus wouldn't just cool. It would sparkle with oceans, rivers, and seas. Let's take that idea further. Suppose the hydrogen bombardment worked. The surface of Venus could end up covered in vast oceans hundreds of meters deep. For the first time, life, maybe even humans, could walk along Venus's shores. But there's a hidden danger. Venus rotates extremely slowly. One day there lasts 243 Earth days. That means half the planet is scorched in sunlight for months, while the other half freezes in darkness. Without intervention, these oceans might boil away on one side, and ice over on the other. How do we fix this? By engineering the atmosphere to circulate heat more evenly, or even, in the most ambitious proposals, by altering Venus's rotation itself. Some scientists have speculated about using asteroid flybys or giant orbital engines to spin up Venus, shortening its day to something closer to Earth's. These ideas are breathtaking and utterly beyond today's technology, but they remind us of a key point. Terraforming Venus isn't about small steps. It's about rethinking what civilization can achieve over millennia. Even if we cooled Venus, thinned its atmosphere, and filled it with oceans, there's still another threat: the solar wind. Unlike Earth, Venus has no protective magnetic field. Over billions of years, the sun has stripped away lighter elements, leaving behind the heavy CO2 atmosphere we see today. If we were to replace it with oxygen and nitrogen, what would stop the sun from tearing it away too? Solutions here range from the scientific to the science fiction. Some suggest creating an artificial magnetic shield, a giant superconducting ring or station orbiting Venus, generating a protective bubble around the planet. Others imagine installing huge orbital mirrors to regulate temperature and deflect particles. It's daunting, but if we solved it for Venus, we'd know how to defend any terraformed world in the galaxy. So now comes the most important question: why bother? Why sink unimaginable energy, centuries of time, and planetary scale engineering into Venus? First, survival. Earth won't be habitable forever. Whether by climate change, asteroid impacts, or the distant death of the sun, our planet's safety is temporary. Terraforming Venus would give humanity a second home, second practice. If we can terraform Venus, we can terraform anywhere. The techniques we develop, sun shades, atmosphere conversion, magnetic shielding, are the exact tools we'd need to make other worlds habitable. And third, destiny. Humans are explorers. We've always sought to turn hostile frontiers into thriving homes. Venus is the ultimate test. If we can conquer it, we prove that no planet, no matter how hostile, is beyond reach. Here's the sobering truth: none of this will happen overnight. Solar shades might cool Venus in decades or centuries. Atmospheric sequestration would take centuries to millennia. Hydrogen bombardment could, in theory, reshape the planet in mere centuries, but only with technology far beyond what we have now. Terraforming Venus is not for us, or even our children. It's a project for generations yet unborn. But that's what makes it beautiful. It forces us to think not in lifetimes, but in civilizations. Before you go, if you enjoyed this journey into the future of planetary engineering, hit that like button, subscribe, and tap the bell so you don't miss what's next. Terraforming Venus may be the boldest idea humanity has ever imagined. To take a planet of fire and brimstone and turn it into an ocean world, alive with air, water, and life. It sounds like science fiction. But every step, from solar shades to chemical reactions, is rooted in real science. The truth is, the universe won't hand us habitable worlds on a silver platter. If we want more Earths, we'll have to build them ourselves. And maybe, just maybe, Venus is the first step.